So, good morning to all of you. So, first I will explain yesterday's topic. Some briefly, I will explain you briefly. So, yesterday we discussed about that bubbler type level indicator, bubbler level type indicator. That is, it consists of a bubbler tube and then airflow meter, and one end we are connected to the compressed air, and then the bubbler tube, one end of the bubbler tube we are dipping into the uh, vessel or a container or a tank containing liquid whose level has to be measured. Then when the compressed air sends through airflow meter into the bubbler tube, then the dipped end of the bubbler tube will occur the air bubbles. If the air bubbles occurs, means that indicates that the pressure of that air is equal to the pressure of the liquid air at the bottom. Then we have to note down the hydrostatic pressure. That means a gauge fixed on the bubbler tube. We have to take down the reading, that is hydrostatic pressure of the liquid. Then this pressure is proportional to the height of the liquid in the tank. That is a bubbler tube, bubbler level type indicator. And the next we discussed about the magnetic type level indicator. The magnetic type level indicator, it consists of a float. The float has having several shapes, right? Maybe in the ball shape or maybe in the rectangular like this. So, so the float, in the float, a bar magnet is arranged that should be placed on the surface of the liquid, which is containing in a container whose level has to be measured. And then around that sealed chamber of the liquid, then there is a magnetic shielding device and indicators. There is a small wafers are there. So when the level rises, automatically the wafers will glow. So beside that, a scale should be arranged. It indicates the level of a liquid in a chamber. So this actually already I explained through YouTube also, so you can get a clear idea. This is meant for toxic liquids. That is poisonous. Toxic means poisonous and corrosive materials, right? And then next we discussed about that cryogenic fuel level type indicators. In the cryogenic fuel level type indicators, a superconductor wire is there. We have to arrange that wire, that superconductor wire in the form of a loop, and then the loop, the bottom of the loop, it should be touched to the bottom of the tank containing fuel, whose liquid has to be, whose level has to be measured. Then automatically, when the level rises, there will be change in the resistance in the superconductor wire, which will be displayed in that high impedance ohm meter reading that should be proportional to the level of the liquid in the tank, that the level of the fuel here, for especially for this one, um, cryogenic. This is for cryogenic fuels, right? That is actually which is used in shapes of rockets, satellites. There, in the rocket engines, the propellant. That means where the fuel is used in, especially in that cryogenic fuels, especially used in rocket engines, right? And then, okay, right. Yesterday we discussed only that three topics. And today we are going to discussing about the flow measurement. In the flow measurement, we are discussing about rotameter and magnetic flow measurement. So after completion of this class, so you can gain a knowledge on a rotometer as well as the magnetic flow meter, magnetic flow meter. Here, what about the flow measurement? So here, before going to this topic, you have to know about the flow measurement. So what is flow measurement? Anybody? Flow measurement. Measurement of flow. 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 Discharge, right? It is a discharge, correct? Discharge. Absolute right. Anybody? Anybody? Can you tell any discharge measurement devices? Discharge measurement. What you seen in the college, where maybe in the lab, to seen in the lab. Anybody? Venturimeter, right? Right. Venturimeter, right? These venturimeter is used to measure the discharge or a flow rate, also called as a flow rate. Orifice, right? Very good. Orifice meter. Pitot tube, right? Very good. Pitot tube, right? Orifice, right? Very good. Pitot tube, right? So that actually you seen in the fluid mechanics lab, right? So any other? So these orifice, pitot tube, and venturimeter, these are flow meters. We can call it as a flow meters. That means a flow meter means this represents with the help of this orifice, venturi, and pitot tube, we can measure the flow rate. We can measure the flow rate. We can also call it as flow meters, orifice flow meter, venturi meter, pitot tube flow meter. This we can call it as a flow meters. But now we are discussing about the uh, flow measurement devices. Here, in the, for example, orifice, with the help of the orifice, so you are calculating with the discharge with the help of some calculations, right? But here you can go for direct, that means that device can measure directly the flow rate, that means discharge. So here, flow measurement is nothing but the measurement of the flow. That is, how much quantity is discharging, how much quantity of liquid is discharging from one section. That means, in the, for example, the water is flowing into the tank. That means into the tank. That means here the water is the that much amount of quantity is discharging from that particular section. That is nothing but we can find out that is the discharge. The discharge is nothing but flow rate. I think all of you know that. What is the unit of the discharge? What is the unit of the discharge? Anybody? Meter cube per second, right? The discharge units is a meter cube. That means here, what here indicating meter cube is nothing but the volume or quantity, flow quantity. Here we are discussing. See here, you observe here flow quantity, and this already we discussed this one, right? Flow rate and fluid velocity, right? Here, this flow rate depends on the fluid velocity, and this flow quantity is also depending upon the fluid velocity. Here, flow quantity, that is how much volume is discharging in a unit time. That is how much volume is discharging in a unit time from one particular section. That is called, in another word, Q is equal to AV. One person written that Q is equal to AV, where Q is nothing but what is Q? Q, discharge. A is nothing but area. V is nothing but velocity. So here, see what I said to you. Flow quantity is nothing but what he said. The Q. That means flow quantity. That means flow quantity is nothing but, in other words, so we can also call as a V. Flow rate is nothing but a Q, and fluid velocity, that is nothing but the velocity is nothing but the flow is moving, the rate, it is per second, it is moving per unit time. The flow is moving, that means liquid is moving per unit time. Yes, Q is discharge, right? So this is the with varying degree of accuracy or fundamental necessity in almost all the flow situations of engineering. Here, this should be studying in oceans or air currents, monitoring gas input in vacuum chamber, right? In vacuum chamber also, measuring blood movement in veins. Here, the measuring blood. See here, blood pressure, right? So we are measuring with the help of one device. We can go for measuring the BAP. All of you know the blood pressure, right? So that means here, yeah, the blood is flowing in the veins. That means flowing. Here the flow rate. How much flow rate? The blood is in the moving in the vein. That means measuring blood movement in a vein. So here measuring blood movement in the here. That means blood pressure. Here pressure means when the flow is taking place, compulsory there will be a pressure difference. Remember this point. So here in the flow meter, so what we discussed there, what is the orifice meter, venturi meter, and the pitot tube? These are the meters. These discharge actually we can get with the help of some formulas. That should be the pressure difference only. So here also measuring a blood movement in a vein, that is the blood flow in the veins is more means the pressure is high. The pressure is high. The blood movement is, for example, it's very slow. Here we can say the pressure is very less, so we can say blood pressure is less, the low. So like this, here the scientist or engineers is faced with choosing method to measure. That means here the scientist or maybe the engineer. So according to the application of measure flow, you have to go for that a particular. You have to choose a particular methodology, or we have to choose a meter for that a special meter. For example, for some applications, we have to go for a venturi meter. For some other applications, we have to go for some other device. Here in these flow measurement devices, there are so many flow meters are there. That is flow meters on one side. On the other side, we can go for with some devices, that is a rotameter, magnetic flow meter, ultrasonic flow meter, turbine flow meter, a hot wire anemometer, laser Doppler anemometer. So these are all the actually we can get the flow rate that should be displayed in the device directly. So that parameter will be displayed directly. These are on the other side. Some of the meters are there. Orifice meter, what we discussed earlier, and venturi meter, flow nozzle, and pitot tube. These three, these four. So according to the application, the engineer can choose the methodology to measure the flow rate. And the for experiment procedures, it may be necessary to measure the rates of flow either into or out the engines, pumps. Here, this here engines, pumps, compressors, and turbines. Here, for example, in the engines, right? In the engines, so water cooling has to be provided in the engine. For example, the heat getting is more thermal energy. So to cool the engine, what we have to do means we have to arrange a water cooling systems. That means in and out. Maybe the pumps, compressors also. Here the compressor means always the compressor. What is the function of the compressor? It will suck the air. Thereby, what happens means the volume increases, the temperature decreases, the pressure decreases, right? When the volume sucked, then automatically in the second stroke, whatever the sucked air will gets compressed. Once it gets compressed means what happens means the pressure increases. Once the pressure increases, there will be a rise in the temperature. Once there will be a rise in the temperature means what happens? There will be heat is dissipating from the compressor. So to cool that one, we have to arrange a water cooling system in that water in and out. Here the discharging, when you get the discharging water cooling out, it should be very hot in condition. So we have to go for cold water in, that is discharging into the pipeline of that compressor, or maybe the engine circulating throughout the engine. So that means whatever the heat dissipating, it will cool that. It will cool. So that means here that means pumps, compressors, right, and turbines, etc. The next radiator, right? Very good. Number 12, lateral entry in cars, radiators, right? We have to circulate the water. That means here what we are concentrating on which topic means here sending of the flow quantity into the pipelines which is arranged around the radiator to cool the radiator. That means here the flow rate is very important, right? So we have to fix the flow rate in such a way that according to whatever the heat delivered, whatever the amount of the heat delivered or heat dissipated from the radiator, you have to send that amount of a flow rate through the pipeline. So then automatically the radiator will cool. If the flow, whatever the flow quantity is decreases means then no need. Here the flow rate is very. We have to set the flow rate according to our requirement that the heat dissipation from that radiator should be equal to that, right? So we have to set that flow rate into the pipeline of that which is connected around the radiator and then out the discharge. So correct, it is correct. Yeah, next we'll go for the next. Then here in this another and it is used in controlling of processes also, some of the controlling processes and operation in industries like chemical plants, some other rayon industries, etc. So this sometimes, for example, if you observe clearly in some industries, the heat dissipation is more there. If you observe the environmental conditions, it should be more than that of that outside temperature, environment temperature. Because why? Because in industries, due to the movement of the components or the machines, thereby the heat generation or the heat dissipated is more when you observe the temperature at that particular sections, it should be more than that of the outside temperature. So here, if a chemical plants is a very the chemical plants, so cooling in flow rate in and out of cooling any one. So it is badly needed, especially in the chemical plants or maybe in the pharmaceutical industries like that. And then see here in industrial organization, flow measurement is needed for providing the basis for controlling of what I said now, controlling process and operations, right? And determining the proportions of the materials engineering, materials entering or leaving, continuous manufacturing. Continuous manufacturing. So what I said now, continuous manufacturing in industry, what happens means the materials are leaving or maybe the entering. Here the heat generation or dissipation should be more. And then night flow measurements are also made. Compressor guns. Okay, compressor guns. Number 30. You said that. Does, so now it is clear, Amma? Here because yesterday and today also here in Tadepalligudam, the environmental is not good. Maybe sometimes the network will slow, thereby the voice may be somewhat disturbed. I hope so. I hope so. The voice may be somewhat a break. Huh? That is the thing. Here, yesterday also, here the environment is not good. Today also, from the morning onwards, there is cloudy only. Here, completely cloudy it is. Then flow measurements are also made for the purpose of cost accounting in distribution of water and gas to domestic consumers and in the gasoline pumping stations. Here, these are the applications where it is used. Here, in gasoline pumping stations, right. And in domestic consumers, that means gas. See here, in our, for example, in household appliances, so we are using HB gas or Indian gas, and then we are connecting to the with the help of the small pipeline to the gas stove, right? So there, the discharge of the gas should be. We have to set. They will set. They will manufacture the cylinder in such a way that. That a pipeline, that is the pipe coming out from the gas, should be the diameter should be in that only, right? So that should be fixed flow rate of the gas into the stove. And for example, another awards in the gas stove, what we are doing, we have to, for example, according to our requirement, we have to adjust it into sim also, right? Sim తగ్గించేస్తాం గ్యాస్, we can decrease the gas. That means here the flow rate will be decreases. So here that should be pipeline that should be arranged according to that particular limited flow rate of the gas only. And in distribution of water, in the water also, see here in the pipeline, so we are storing in the tank, and then from there we are using in all maybe the bathrooms or some other outside, we are using by arranging some taps, right? So here in the taps, so we have to rotate the that we have to rotate the tap, and then thereby the flow adjustment will take place. That is, the flow rate changes. The gasoline pumping stations. See here, if you observe gasoline pumps, even in Vizag steel plant also, the gases will flowing through pipeline, the gasoline pumping stations. So here to heat in a furnace, so more amount of heat is required for that. Gasoline is sending from the from the station to the wherever required. That means to get more amount of heat, to produce more amount of heat. Or that means so in Vizag steel plant we have to melt the material up to 2000 degrees centigrade. So for that we need the heat source there. From the station there will pumping the gasoline pumping through large pipelines with a huge diameter, and then sending to wherever the heat is required. So like that gasoline pumping stations. Mostly 8 years back, I seen in Vizag steel plant the gasoline pipelines are bursted, and the damage occurs more in that. Huge loss occurs in that Vizag steel plant. Sometimes it's a very danger that supervising is needed for that. Here, what we are discussing mainly, that gases passing through the pipelines should the flow rate should be, we have to maintain correct, and the pressure also we have to maintain in the required one. Otherwise, it will create problem. That is the thing. Then in this we will discuss about the rotameter. Today we will discuss about the road. That is the introduction about the flow measurement. Um, See here, this meter, it will takes only 5 minutes. Flow meter. See here in this, if you observe clearly, this is a in. Here the diagram is written wrong. See here, this is the rotometer. Actually, it is in our lab instrumentation control system. It is a long and tapered glass transparent tube. This tube is a, see here, if you observe, so 1 minute. See here, this is a long tube, right? This is a long tube. See here, if you see, I've observed clearly. This is a long glass transparent tube. Long, long glass transparent tube. It is. So here the flow is taking place at the inlet, and here the outlet, that is discharging. Then here, so here wherever you can use that one, it is should be connected to that point. It should be connected to that point. It should be connected to that point, right? It should be connected to that point. And here, see here we are sending some water liquid, right? Example. Here inside the transparent glass tube, that is a tapered glass tube. Here we are arranging a float. This is a float, right? This is a float. So here, if you observe it here clearly, this is the float. When the float is correctly at here, this is the arrangement. See here. Again, I'm writing here. See here, this is the arrangement. See here, this is here when this float is correctly at this position, then at this position, there is no flow. See here, if you observe it here in this figure, if the flow is at here, here the flow is coming out, it is completely obstructing. See here, there is no flow. It stops. When the tap opens, then automatically the flow occurs. Then automatically this float will moves up. Here, if the flow is more, automatically this float will rises or downs. That is depending upon the flow change. If the flow changes automatically, maybe the float rises up and down. So here, if when the float rises on the transparent glass tube, there will be a scale is provided. This is a scale. This scale is provided. So here, when the bob or the float is at here, then we have to note down the reading directly. This indicates the flow rate directly. It is available in the INCS lab, Instrumentation and Control Systems lab in our college. So here, so here, what here we are understanding here, it is a transparent tapered glass tube. So here it should be like this. Transparent, it should be like this. Here, this is if it is not like this. Is it like this? So in between this, a float is there here inside the float. When the flow changes, automatically this float will rises up. That is a variation of the pressure flow. Then automatically wherever the float is unstable, we have to take down the reading. That scale is mentioned on that glass tube, transparent glass tube. Then according to that, we have to note down the that is measurement of a flow of maybe a liquid, maybe a water, or maybe some other. Here in this, that is here inlet flow to stop. This is inlet, and this is the minimum flow. See here, when the bob float is at here, this is here. If you observe it here clearly, the flow will occurs takes place from the side of this one, from the side of this one, right? Here, if you see clearly at here, right? At here, see here, this is the arrow marks clearly. It is mentioned. Here it goes like this. Here the arrow marks. Here, see here, the flow will occur like this. That means the flow will take place not like this. See, that means due to the bob displacing, maybe it rises up or down. So thereby the discharge rate changes, discharge of flow changes, discharge. Right, petrol bunk, right, in petrol bunk, right, correct, right. So this is simple. This one we can call it as a rotameter. Here, the float is at here. What we have to observe, there is flow rate is almost all negligible. When the float is at the middle, then the minimum flow rate, that is, the flow rate should be very less due to the annular area at the bottom is very less because it is tapered. And when the float is at the top, that is, it rises up, then the maximum flow, it is a maximum flow. So due to the maximum area, that means it is a tapered because the flow area is more. The flow area is more. So next we'll discuss the next one. This is completely explanation of that. So I will share you the WhatsApp group and advantages. Simplicity of operation. It's very simple in operation. So when you adjust when you rotate the valve, then automatically the flow occurs, takes place. Then the wherever the float in that glass, tapered the transparent glass tube, tapered transparent glass tube, the float directly we can take down the reading. That is simply simplicity of operation. You can take the reading very easily, and the installation is also very easily, and relatively it is very low cost, and handles a wide variety of corrosive liquids. That means it handles a variety of corrosive fluids, easily equipped with a data transmission, indicating, and recording device. That means in sometimes we can get a digital. We can go for recording the parameter also, indicating or recording. Disadvantages: a glass tube subject to maybe the glass tube sometimes breakage takes place due to high pressure in the flow. Limited to small pipe sizes and capacities, less accurate compared to where. That means it is very less accurate. The accuracy is very less compared to that of the Venturi and R5 meter. Most be mounted vertically. So this is very important. Actually, this meter we have to mount vertically. It is very, very important. It's we have to, otherwise, that is only if you mounted horizontally or maybe inclined means it will not work. So that is the disadvantage. Here, and the disadvantage, we have to mount that one vertically, right? Subject to oscillations. Here, some vibrations is more where we have to measure this or rotameter is not useful to work because we cannot get the readings accurate. So that is subject to oscillations. For example, we have to measure some flow rate there, the vibrations or the machine is working more, then what happens means so we cannot get the correct reading. That means the reading is not accurate. So at that situations, we cannot use this type of rotometers. And the next magnetic flow meter. So 1 minute. So 1 minute, 1 minute. So it is visible to all of you. It is visible. Okay, okay. So this is a very simple magnetic flow meter. Uh, Magnetic flow meter. In this, we'll discuss about. So it's very simple. This is also very simple instrument. Here, this magnetic flow meter works on the principle of Faraday's law of inductive voltage. So here, Faraday law of inductive voltage. So here, in this Faraday's law of inductive voltage, all of you know that you know the formula E is equal to BLV. E is equal to BLV. Here, where E is nothing but induced voltage, and B is nothing but a magnetic flux density. L is the length of the conductor or length of the uh, pipe, and V is nothing but average velocity of the conductor, average velocity flow of the conductor. Here, where E is nothing but induced voltage, B is magnetic flux density, L is the length of the conductor or pipe, and here V is nothing but average flow velocity. Here, if you observe clearly at here, here this is a pipe. See here in this figure, you can. It will take only 5 minutes. Okay, then the time is over. So it is now the 9:15. It will take only 5 minutes. I will take that next. So here, the pipe is placed around the in between the magnet. That means around the magnetic coil. Here in the pipe, here the flow is taking place. The flow is takes here. See flow. Velocity is V. V is the velocity. This is V. The flow velocity in the pipeline. This pipeline here we have to measure the flow. Here some liquid flow is taking place. We have to measure the flow rate of that liquid in the pipeline. So this pipeline you have to place or you have to arrange in such a way that around the magnetic coil, around the magnetic field, or we have to subject it to the magnetic field. Then what happens means whenever the flow takes place, this flow cuts the magnetic field. This flow cuts the magnetic field. So then automatically there will be a change or whatever the induced voltage changes. This induced voltage is nothing but we can directly proportional to the flow rate. It is proportional to the flow rate. Number 330, Karthi. Any questions? Any questions? Again, I'm repeating all of you. See here, clear. This magnetic flow rate is mainly depends upon the okay, right? Okay. Magnetic flow, this is magnetic flow meter is mainly depends upon the Faraday's laws of induced voltage, that is E is equal to B plus V, BLV, where E is nothing but induced voltage, B is nothing but magnetic flux density, L is the length of the conductor or pipe, V is nothing but the average velocity flow in the pipeline. So here we have to arrange a magnetic coil or otherwise a, a pipe carrying some flow of liquid whose flow rate have to measure has to measure. Then we have to place this arrangement of that pipe in the magnetic coil, or we have to subject it to the magnetic coil. When the flow takes place in the pipe, the automatically it will cut the magnetic field. There will be a change in the induced voltage. That voltage is proportional to the flow rate in the pipeline. So this is very simple. See here, if you observe here in this, I think all of you know this. This is the flow rate, and perpendicularly induced voltage, and the magnetic field is applied perpendicular. That means it is a thumb rule. I think all of you know. One side is a pipeline. See here, if you observe it here, one side is a pipe is flowing, and the other side is what happens means induced voltage developing. Other side magnetic field, subjected to magnetic field. So here, this if you observe clearly, this is a pipe flow in one direction, and it is perpendicular. The induced voltage developing is perpendicular, and this is the magnetic field. This is the magnetic field. Magnetic field applied is so that means pipe flow, induced voltage, and the magnetic field. These three are perpendicular to each other. This is completely an explanation. And the advantages, go for advantages. So here it can handle greasy materials, greasy flow. That means lubricants maybe in some liquid state with its thickness is more. And it handle corrosive fluids also. It handle corrosive fluids, and the accuracy is very good. And it has a very low pressure drop. And the disadvantages is the cost is more. In the rotometer, the cost is very less and heavy and larger in size. It's a very, the equipment or the device is very large in size. Explosion proof when installed in hazardous and in electrical area, that hazardous electrical areas. And it must be full at all times. It means here maybe here the explosion proof when installed in hazardous electrical areas means sometimes we can find out the flow rates of an explosion, some liquids which are very dangerous. For that, we have to measure the flow rate. So, with the help of some maybe the electrical connections will be mismatched, then automatically it's very difficult. That is a hazardous electrical areas. Great. Thank you to all of you. Now we respond one by one. I will take the attendance. Respond one by one. So number 20, number 20, right, and 81. See here, and then one thing I have to inform to you. Already assignment one is uploaded in LMS Digiversity up to 19th. You have to write on the paper, take a plain papers, and then you have to write down the assignment unit wise, and then you have to scan that one. You have to convert into PDF. That PDF you have to upload in LMS. Correct. And the 18th batch 81, next 18th batch 81. Option number. Right, one, number one, two, three, three, five, six, six, seven, eight, nine, 10, 11, 11, 12, right, 13, 14, okay, right, 15, okay, present, 16, 17, right, 17, right, 17, right, present, 18, 18 present, 19 present, right, 19, 14, 7 present, okay, 20, right, 21, right, 11, 11 present, okay, 9, 21, 22, right, 21, 305 present, okay, 23, 24, 24, 24, 24 option number, 25, 26, 25 present, okay, 25, okay, right, 20, 18, 18 present, 308, okay, 1 minute, don't do like that, right, number 25, okay, 26, 24 present, 24, right, 20, 27, 27, 28, 28, 29, right, 28 present, 29, 30, 31, 32, 31, 32, 33, right, 33 present, right, and 34, right, okay, 35, 35, 35 option, 36, 37, 38, 39, 40, 41, 42, 42, 43, 42 option, 42 number is not there, 43, 43, 44, right, 45, 46, 47, 48, 49, 48 option, 49, 50, 51, 52, 53, 50, 54, 53, 53 अम्मा, 54, 55 right, okay, 56, 57, 58, 57, 58, 58, 57, okay, 58 option, 59%, 60, 61, right, 60, 61, right, 18th batch, 81%, okay, 53%, okay. The next 61, 61 number, 60, 61, right, okay. The next lateral entry 1, present 2, 3, 3, 4, 5, 6, 7, 6, 7, 6, 6 lateral to 6 option, 7, 8, right, 8, 9, 10, 11, 12, 11, 12, 11, 12, 11, okay, 12 present, 11, okay, 13, right, present, 14, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 26, 27, 28, 29, 30, 31, 32, right, 33, 34, 35, 36, 35, 36, 37, 37, 38, 39, 40, 40, 40, 40, 41, 42, 43, 44, 45, 44 option, 45 present, 46 present, 47 present, 48, 49, 50, 51, 52, 52, 52, 53, 53, 54, 55, 56, 56, 57, right, 57, okay. Here, see here, regular absent is number 1, 2, 3, 6, 10, 13, 24, 35, 43, 58. 24 present, no? Okay. 43 present. Okay. 17, 302 present. See here, again I'm reading. See here, all of you see here. For regular, 1, 3, 6, 10, 13, 35, 58. The regular absent is. And then section B, lateral entry, 6, lateral entry 6, 11, 14, 31, 35, 40, 44, 48, 49, 52, 56. These are the options. Lateral entry 16 option present, okay, right, given present. 8 lateral entry 8 is also present, and 13 lateral entry 13 is present already again. 4 is also present. 56 lateral entry present. Okay, thank you to all of you.